Tonight's, this is the first ever informational meeting of the Instream Flow program. The rules were passed back in 2018 that changed everything that we do, and we added this as a way to inform people ahead of time about what we were going to say during the public hearing so that they had at least a couple weeks to absorb it. So here we are tonight. Are we recording?
We are recording.
So we are recording at this moment. We are meeting here at the Ulstead Town Hall, which is in the back of the fire station, and it is 7 o'clock on September 27th, 2021.
It might be good to just do a sound check for Kathy or Neil or something. Make
All
sure
right.
you can hear. Oh, there, she's smiling. So is Neil. Excellent.
We've got somebody saying that they're happy at least. All right, good. So let's get on with the show. Yes, please. All right, so this is part of the public review process of the protected in-stream flow study that's been completed in draft form by Gomez and Sullivan. The public review process is a preliminary step towards establishing as water quality standards the protected in-stream flow criteria, which is a series of numbers that describe how the stream should be maintained in order to support the various entities that use the water that are basically flow dependent in-stream uses of the river. So things like fish, obviously, but also things like riparian vegetation and wildlife and recreational uses. So as we move forward, this will go through the public hearing process, which is a formal comment period. And that comment period will inform the final draft of the report, and then that will go to the commissioner when we complete that final draft, and he will then determine whether or not to establish those criteria as the water quality standards for flow for specific to the Cold River.
Introduce everybody.
I did not introduce everybody.
Like yourself and other people.
I introduced myself once, but no, I am Wayne Ives, the in-stream flow specialist. Tonight we have with us Joe Schmidl. He's the in-stream flow environmentalist in the back row here for those of you who can see he waved. And also Ted Deers, the administrator of the Watershed Management Bureau, which is the program, the bureau under which I am housed. But I'm housed underneath the Rivers Management and Protection Program, which is managed under Ted and above me by Tracy Sales, who's sitting over there. And we also have with us Ian Corelli. He is the chief scientist involved with the Gomez and Sullivan Engineers out of Henniker, New Hampshire, and they have done the field work to determine the habitat uses of the various fish and riparian vegetation and wildlife and the recreational uses of the river. They've done those studies to determine these information that they've gleaned from the river into these flow criteria that we hope to establish as the water quality standards. So now we've introduced everybody and we can actually get a little, next slide here. I guess I can't. All right. This informational meeting is part of what we included in the in-stream flow rules. We made it a part of that rules, as I said before, so that people would have an opportunity to understand everything that we've put into this protected in-stream flow study before we go to the public hearing process. So that's not the first time that you will have heard of it. When we get to the public hearing process, we will open the floor for comments and allow people to take what they know of after having read the report or from sitting to this information meeting. They can then make whatever comments they choose, and we will use those comments in determining what, if any, changes we want to make to the final version of the protected in-stream flow study report for the Cold River. So we will hold the public hearing here on October 18th, the same night. It'll be a Monday, and it will be from 7 to 8:30 p.m. And then we will have at least a 30-day comment period, which takes us out to the end of the day, November 17th, 2021, so 4 p.m. And the address to send comments to is there. So the comment period essentially is available to you from now until November 17th. And that mailing address or that email address is available for you to contact me with those comments. So in brief, I think I've kind of probably covered a little bit of this already. The study itself was conducted by Gomez and Sullivan out of Henniker. The protected in-stream flow requirements are developed under requirements that are in statute that then is turned into the in-stream flow rules, which are ENVWQ 1900. This draft report that we've completed so far goes through those two next steps of public review, and then it goes to a final report that goes to the commissioner, and the commissioner then establishes those protected flows if we've done a good enough job in developing and explaining them. And now I'm going to turn the table over to Ian so that he can go through the information that they've collected for the Cold River and how they got to generate the protected flow criteria.
Thanks, Wayne. Okay. Well, I'm Ian Corelli. I'm a fisheries biologist with Gomez and Sullivan Engineers, and I've had the pleasure of working with New Hampshire DES on developing the protected in-stream flows for this beautiful river out here. Just a little background on the program. The New Hampshire legislature created the Rivers Management and Protection Program with New Hampshire DES in 1988. This program protects certain protected rivers in New Hampshire for their outstanding natural and cultural resources. It is a cooperative approach. The New Hampshire DES designation of significant rivers manages and protects the river's natural resources combined with the local development of river management plans. The Cold River was accepted into this program as a designated river in 1999, and all approximately 23 miles of the Cold River are designated. With the in-stream flow rules, the protected in-stream flow study shall be conducted, develop a study report that includes those proposed protected in-stream flows, and that's what we're talking about here today. A little bit of background on the Cold River. Many of you are probably familiar with it. It flows from Crescent Lake to the Connecticut River through the towns of Unity, Ackworth, Leominster, Alstead, Langdon, and Walpole. It has a drainage area of 102 square miles. There are two active dams along the river, Crescent Lake and Vilas Pool, neither of which significantly alter the hydrology. Tributaries in the watershed include Dodge Brook, Honey Brook, Bowers Brook, Great Brook in Ackworth, Warren Brook, and then Great Brook in Langdon. There's also smaller tributaries as well. Protected entities on the Cold River include diverse habitat, which is dependent on sufficient water in the river. Several fish species live in the river, including various minnows, native brook trout, and also stocked trout. There are several riparian or shoreline plant species along the banks that rely on the river and its processes and its flows. And there are recreational opportunities such as angling, swimming, canoeing, and kayaking. So I'm going to talk a little bit about hydrology and just give you guys a little information on that. Water flow in a river is typically measured in volume per unit time. In this case, cubic feet per second. I don't know how many of you have looked up the flows on the internet. It's posted online because there's a USGS gauge right here in Alstead, right down the road. It's cubic feet per second you'll see as CFS or feet cubed per second. Usually we refer to it in our report as CFS. So if you see that abbreviation, that's just what it means. It's a measure of flow. In this plot right here, you can't really see the numbers very well, but on the last date, you can see where the flow came back down. That was about 50 CFS, for example. So if you have any questions about reading a hydrology graph, feel free to ask. The period of record of the data set that we had was relatively long. We used the New Hampshire DES extended time series from 1950 through 2017 in our assessment, which I'm going to talk about a little bit later in this presentation. It included data from the historic Drewsville gauge, which had some of the older data. Any gaps were filled with the New Hampshire DES's approved QPPQ method, and the Alstead USGS gauge had data from 2009 through 2021. So the purpose of this study was to determine what is considered enough water in the river for the cold river protected entities. So the fish, the riparian vegetation, recreation, things that rely on river flow. We determined the flow on the cold river that supports the fish, the riparian plants, and recreation at different times of the year, which is and when I refer to these flows, they're called protected in-stream flows. These are based on, and the whole study was based off of the natural flow paradigm, where we acknowledge that there's a variation in flow among years and within years that's necessary to maintain or restore native aquatic ecosystems. This variation relates to the natural magnitude, timing, duration, frequency, and rate of change of flows in the river. So this is a little on our approach. We did a detailed identification of all protected entities present on the cold river by performing what we call on-stream reconnaissance. This was basically walking the entire river after doing a little background information gathering on the internet. So we traversed the entire river. We mapped it all out. We used published scientific methods then to determine the protected in-stream flows for fish, riparian plants, and recreation. This included habitat hydraulic analysis and habitat time series analysis for fish species, the floodplain transect method for riparian plants, and recreation surveys and internet search for the recreational components. And I'm going to touch on each of these in a little more detail in this presentation. So for the reconnaissance and study site selection, as I said, we traversed the entire river by wading from Crescent Lake to the confluence of the Connecticut River. This was to confirm the presence and occurrence of protected entities and designated water uses. We also documented different fish habitats present in the river and selected specific sites for assessment of riparian and fish habitat. And we also documented recreation locations wherever we found them. So some of the sites we selected along the river, we chose specific locations and established what we call transects. Transects are basically a cross section of river where we can see different elevations and different habitats as we go across the stream. We selected several representative transects at different points along the river, and these were for the most part, for the aquatic and riparian assessments. We treated them as two separate assessments with their own study designs. So for the floodplain transect method and the riparian habitat assessment, we chose locations with various and/or unique wetland and riparian communities, and there were 6 of these in free-flowing reaches throughout the river. For fish habitat and the habitat hydraulic modeling portion of this assessment, we used a stratified random design for statistical rigor, and all that really means is we delineated the river into different segments and then randomly chose locations within those segments to be unbiased in our choosing of habitat areas. Overall, we delineated 4 river reaches based on the reconnaissance, but 2 of them contain most of the free-flowing habitat. The furthest downstream one, very close to the Connecticut River, was very short and sometimes backwatered from the Connecticut River. So we did not choose that specifically for habitat assessment. The reaches furthest upstream were very beaver dominated, and there was many areas that were backwatered by beaver dams, which affects the fish habitat modeling. And generally those backwatered areas are not as sensitive to flow change as areas like riffles and runs that tend to be in the most of the mid sections of the stream. For the fish habitat, we selected 13 transects from what we call in the report reaches 2 and 3B. Now reach 2 has, as you can see up here on the map, it's kind of small, but it's a relatively long reach and contains a lot of riffle habitat, free flowing, and could be sensitive to flow changes. Reach 3B was a section down below the Drewsville Gorge, and it contained relatively good fish habitat, and also was not as affected, or at least it didn't appear to be as affected by some of the historic stream work that had been done in the past. For example, right here in Alstead was part of Reach 3, but there was a lot of work done in the past on fish habitat, or on aquatic stabilization right there. So we chose not to select locations in that reach. I see a question.
Yes, it's difficult to see where those reaches are from back here. Can you point out on the map where reach 2 is and 3B?
Absolutely. So this is color coded. This light up here is reach 1, that was mostly backwatered. Reach 2 starts right here at where there's kind of a major bend in the river. And it reach 2 extends all the way down, I believe, to Vilas Pool. And then reach 3 starts at Vilas Pool and goes almost, not quite, about a mile from the river mouth.
So is that 3 or 3B?
3B extends from Drewsville Gorge to the river mouth. We called all of this reach 3 from the base of Vilas Pool down to the beginning of reach 4, about a mile up, but we only chose representative locations from 3B. It's a little bit complicated in that way because we had to deal with in-stream work that would have affected the habitat measurements. So we didn't want to choose somewhere where there was definitive work that had been done in the river. However, most of the pool riffle run habitat in 3A and 3B did not seem all that different, but we just didn't want to bias our study to those affected areas. Does that answer your question? Good. Okay, so for recreation, flow-dependent recreation on the Cold River includes angling, which was observed primarily at Vilas Pool and several pull-offs along the river, boating. Facebook outreach indicated that there was some whitewater boating in the area. We did a lot of searching to find anybody boating on this river, and we essentially couldn't find it. The opportunity is there, and people were kind of curious about it on whitewater boating groups, but it doesn't appear to be a utilized resource. And if it is, it's somebody dropping their boat in and making a break for it rather than knowing what flow they really need to navigate the river on. So we just didn't have a lot of good information on defining a recreational flow that people would target. Swimming does occur in the river. Vilas Pool was pretty popular, and there was other private locations along the river that we observed people swimming in the summertime. Some recreational sites identified during the reconnaissance included informal pull-offs and trails along the river, Vilas Pool, Bragg Lane Park, and the Cold River Road Trail. We conducted several field observations, online outreach, and recreational surveys to collect the data we got at various times of the year, at various flows in the river, and it was a little bit hard to get out there at times, in the early part of the pandemic, but we made do with what we had, and we tried to do a lot of online outreach as well to make up for any time lost there. Before I go on to the fish habitat assessment methods, which gets down into a little more detail, does anybody have any more questions before I go on?
Hey, can you just say for anybody online, if they want to question, just use the raise hand or
Yep.
they can use a chat.
Okay, so yeah, anybody online can raise your hand or use the chat function, and if I see it or Ted sees it, we'll do our best to respond to that. Okay, just a kind of a crash course on fish and aquatic habitat, so you're familiar with some of the terms I may use. Macro habitat includes broad river characteristics, food supply and predation, and water quality and temperature, things that are overall drivers that are on a larger scale than some of the smaller habitat pieces we tend to look at, which include mesohabitats, which for example include pools, riffles, runs, and also microhabitat, which we measure at these cross sections, which includes slope, substrate and cover, water depth, water velocity. These are habitat characteristics that fish or aquatic organisms tend to seek directly. There's published literature on microhabitat characteristics that are preferred or used. Okay, so for our fish habitat analysis, we mapped the mesohats in the river, as I mentioned during the stream reconnaissance. So that was pools, riffles, runs, backwaters. Those were really most of the major ones. There are a few minor ones, such as step pools or cascades. We selected study transects in different mesohabitats, and we collected microhabitat data at 4 different flow rates at each of those 13 fish habitat transects. That included basically a survey of substrate across the entire river. Substrate is, whether it's boulder, cobble, gravel, mud. And we also, at the 4 different flow rates, collected water depth and velocity. We collected topographic survey data across the river to get the channel shape at each location. We selected fish species and life stages to evaluate, and I'll touch on that a little more in a minute. We developed hydraulic and habitat models for the various species and life stages, and we analyzed habitat time series data within relevant bioperiods. So touching on it in further detail, we mapped approximately 21 miles of river, 274 riffles, 249 pools, and 170 runs, so a lot of different mesohabitats along the river length. Approximately 9 miles were riffles, so it was heavily dominated by riffles. There was a decent number of pools and runs, and like I said, up in the furthest upstream area especially, there was a lot of backwater habitats due to the beaver activity. The transects we selected, as I said, were in Reach 2. We selected 4 riffles, 2 pools, and 2 runs. This was all based on the amount of habitats, mesohabitats that were there. So mesohabitats in Reach 2 were very heavily dominated by riffles. So in order to get a good sample size in the riffle, we collected the most locations in different areas along that reach in riffles. Reach 3, we selected 2 riffles, 2 pools, and 1 run. There was relatively little run habitat in Reach 3, but there was a good number of riffle and pool habitats. And the habitats down there compared to Reach 2 tend to be very long. So the riffles and the pools were long, the pools were deeper than in Reach 2. That's why we divided those reaches separately. For field data collection at each location, we strung a rope across the river, perpendicular to the flow. We collected bed elevation with a survey total station, substrate type by basically looking down at the area around where we were putting our survey rod and determining what the substrate type was. Water depth was collected with a digital flow meter that has a depth staff that goes along with it, and velocity was also collected with a flow meter. We collected depth and velocity when average river flow was as low as 4 CFS. You guys probably would recall last year was a very dry year. We got some pretty low flows to evaluate, and flows up to approximately 121 CFS. So we got a pretty broad range of flows that we were able to get out there and collect data on. The fish species selected for evaluation were based on the target fish community, which was developed by Gomez and Sullivan several years ago for DES. And the target fish community represents the fish community that would be expected to exist at the Cold River at the present time, but isn't necessarily the community that's actually in the river, because there are non-native species in the river. For example, smallmouth bass are in the river, but smallmouth bass were not included in this target fish community development. This was really for native species. The information that came into target fish community development was gathered from several rivers across, I believe, the Northeast. Along with the fish that were from the target fish community, we also evaluated anadromous fish, which swim in from the ocean to spawn and then either die or head back out, but leave their progeny to grow before they eventually go to the ocean. These include Atlantic salmon, American shad, river herring, and sea lamprey. And each of these species has their own microhabitat preferences, primarily for depth, velocity, and substrate, which were obtained from published literature, which are also called habitat suitability indices, or HSI. You may also hear the term habitat suitability criteria, or HSC. They're often used interchangeably. For the hydraulic modeling, as I stated, we took the measurements at 4 different river flows. We used a program called PHAB-SIM to model the water depth and velocity at additional flows below, between, and above the flows we measured in the field. PHAB-SIM uses the Manning equation to predict water surface elevations and mean water column velocities at each transect for modeled flows using the field measured data. So essentially, we went into the field for 4 different conditions, determined how fast the water was going, how deep it was getting, and then we modeled where it would be in between, and also were able to extrapolate it out further from the locations we assessed. The hydraulic model also helped with differing drainage areas at each transect. So further upstream, there's less river, or less water, than there is further downstream after you have tributaries come in. So we were able to back calculate drainage area from those areas, and also confirm that the drainage area calculation was relatively good. So the results at each transect were prorated by the ratio of the drainage area in order to standardize results to the USGS gauge. We did not want results at every single transect downstream. We wanted to combine it in one large-scale model so that DES could look at the USGS gauge and determine the habitat condition in the river. So it's hydraulic modeling gets a little complex. I'm not an engineer. I tend to collect the data for the model, and then modelers do that work. For the habitat modeling, we used the results of the hydraulic model and incorporated those habitat suitability indices for each of the fish species into the software to model habitat at flows ranging from 2 to 255 cubic feet per second. So you recall we evaluated, or we went out into the field and we gathered data between approximately 4 and 121 based on some rules that the engineers and modelers use. You can only extrapolate so far. So our window of extrapolation was 2 to 255 CFS, where we thought we could reasonably predict habitat conditions. For winter habitat, we did not use the HSI curves because they're not appropriate for winter habitat use. The habitat suitability index curves were primarily developed for certain activities that fish undergo. For example, spawning and incubation, or summertime habitat foraging and feeding. Fish behave differently in the wintertime. They tend to hunker down, find slower water. They don't feed as much. And probably one of the better habitat metrics for winter that we found was wetted area. So basically the area of the stream that remained wetted, we used for a winter habitat assessment. We created curves of available habitat versus flow, which you can see an example right here for black-nosed dace adults, which is a species of fish that are in the stream and in the target fish community, a relatively dominant species. And we use these curves to develop a habitat time series based on the existing flow time series. So what we did there was we had all of those years of flow data that I mentioned earlier when discussing hydrology. And based on this relationship, for example, you could see here that at 50 CFS at the Cold River gauge, we predicted a weighted usable area or habitat area of about 1,200,000 square feet. So that's just an example. I can't remember if this was reach 1, reach 2, reach 3, or combination, but we did combine them in the report. And we did that for several species and life stages. And then took it a step further. We defined bioperiods based on hydrologic breaks within the data set. What this plot shows is the 75th percentile, median 25th percentile, and the minimum flows on a given day of the year over that entire long-term hydrology data set. And we can see distinct breaks, and often these breaks also coincide with how fish behave in the stream. Certain species perform different activities at different times of the year. You can see here, it's a little hard to read, but the bioperiods included winter survival, spring freshet, sucker spawning, springtime anadromous fish and resident cyprinid, which are minnows, spawning, rearing and growth, which was a lot of different species that reside in the river, fall salmonid spawning, specifically brook trout and Atlantic salmon. And then we go back into winter survival in December. Yes?
Could you kind of explain that graph a little bit more detail? I can't see any of the wording up here, and I don't know what that elevation is or the colors
Sure.
that represent.
Sure, the y-axis on the up and down is flow.
Okay.
The x-axis is day of the year, and the labels are months, so January, February, March, and so on. So one way to look at this is if you were going to predict when the spring freshet was going to occur, you would look at these flow statistics and say, well, when is the river going to come up? And in this case, there's a pretty solid break pretty close to March 1st, where a lot of the flow statistics start to increase, whether it's 75th percentile, median, 25th percentile. Those ones tend to increase right there. Minimum doesn't necessarily until a little bit later. There were probably some dry springs where the freshet may have been delayed. So there is variability there. But we did our best to try and define where those breaks would be, and also kept in mind when certain fish behaviors were occurring. So, for example, from mid-April through early July, we have a descending hydrograph where the flow is coming down, but different fish spawn at different times in the spring. Some spawn earlier, some spawn later. So based on that, we positioned them at different time periods within this hydrology data set.
What are those labels on the top?
Those are the names of the bioperiods, so winter survival, freshet. They are in the report as well. You could probably read it better in the report. So starts with winter survival on the left, freshet, sucker spawning, springtime anadromous fish and resident cyprinid spawning, that gets you out to early July. Midsummer is rearing and growth. Fall salmonid spawning is late September to beginning of December, and then you get into winter again. So for each of these periods essentially got their own analysis based on the species that were there and the flows that were there. Yes?
How does flooding skew your average data?
So
set?
flooding-
You don't see the flooding.
Right. Flooding shouldn't skew this data set because I didn't use maximum. I didn't put maximum on here. Otherwise, it would be all over the place if you included the flooding. There would, because it was such a long-term data set and there were floods at different times of the year in different years, you'd see a lot more variability. This was really trying to pare down the primary patterns. And these statistics are percentiles and medians, which aren't skewed by high flows. The way the statistics work, they don't actually get skewed. Okay, so from that habitat time series that we developed for each of the bioperiods and each of the species within a bioperiod, we developed these uniform continuous under threshold curves, which are pretty complicated to understand. We applied them, like I said, to all species and life stages for each bioperiod. They're based off of for the different species, they were based on the weighted usable area curves for most of the bioperiods where we thought they were applicable. And like I said, we used wetted area for winter. We used gauge height for the freshet because gauge height really affects how high the river comes, and the freshet really affects the riparian areas, probably more so than the fish habitat. And that seemed to be the better indicator of what would affect riparian habitat. So inundation is related to height of the water for the most part. There's a lot of complicated math that goes into this approach, and I'm not going to touch on it here. If you are curious about it, I'd recommend reading the report. It goes into a lot of detail on it. I will say that we had some general rules coming into interpreting these curves to determine the common, critical, and rare habitat magnitudes on here. So what we see on this plot, in the left side, these are very rare occurrences. So all these different lines on the screen that are different colors are percent of habitat. You can see I have a key in the upper right. It runs from 10% to 90%. In this case, for this species, the lowest amount of habitat, I believe, was around 20%, which was the yellow line, all the way to the left. So 20% of habitat for this species occurred only very rarely. For the most part, flow in the river provided habitat higher than 20% of the total fish habitat that is available to that species in the river. But these are, habitat occurrences that can limit fish populations, and they occur with low frequency, but they also occur at certain durations. So for example, where we have a tiny green circle right here, there was a slight bend in that curve. And that was one of the keys that we used to interpret kind of where we were going to put some of these breaks. And this was consistent with some other, the same methodology used in other rivers that have already been evaluated by DES, such as the Lamprey and the Sauhegan. And where those bends in the curve occur, there's essentially a change in frequency of duration. So as you go up in a higher duration event, for example, a event with 20% habitat that is a very low flow for this species that provides it. If it goes on for 10 days, it could be pretty bad. But if it goes on for 20 days, it's even worse. But it occurs less frequently at that longer duration. Usually there's some increase in flow that would break that low flow period. But they do occur. There are some long duration, low habitat periods that do occur. So based on the shape of these curves, we identified the common, critical, and rare habitat magnitudes, which are the lines. And the way the lines are spaced, if there's a gap, that kind of determines where we would put that common, critical, or rare magnitude. In this case, we chose 20% for the rare. We chose, it looks like approximately, they look the same up there, but it looks like probably less than 50% for the critical, and then common was all the way up at near 90% of habitat at these certain durations that were chosen based on the bend in the curves. So the bends in the curves define where the critical and catastrophic durations are for each habitat magnitude. And critical durations are the lower line. So this could be bad type of line. And then the catastrophic durations where fish populations could be in really, really bad shape are the upper line in the purple circles. So I don't know if that made any sense to anybody. It took me a long time to wrap my head around it myself. It's even harder to explain. It's probably written up better in the report, but
it's basically a frequency analysis of the duration and magnitude of the stream flows and how the frequency changes. You're finding the inflection points.
right.
Just like that.
Just like that.
However, it's not only stream flow. This was actually habitat itself, which is related to stream flow with one of those flow and habitat curves. So it's not a direct stream flow correlation. It's a habitat correlation that's provided by the stream flow. Okay, so common, critical, and rare habitat magnitudes. As I said, we searched for gaps between the lines. The rare was the first line from vertical most of the time. Sometimes there was little lines all the way to the left that were completely vertical. We looked for the one that was just to the right of that, for that first threshold. Critical and common lines were further to the right. They occur more frequently. Then, as I said, the critical and catastrophic durations are along inflection points where the curves bend. I don't expect anybody to read all of this. It's also very small, but I just wanted to demonstrate that we used a lot of the target species and life stages for the various applicable bioperiods. We looked at a lot of different ones in the different bioperiods, but they weren't always used. For the most part, they were. There was a couple that dropped out of the analysis after we started developing weighted or habitat versus flow curves, such as sucker spawning. The white sucker was not used in this case because they were actually high flow limited based on their habitat curve in the springtime, and that would have essentially messed up this U-cut analysis, because of instead of evaluating a low flow, we would have been also mixing in high flows that reduced their habitat level. And I'm not really necessarily sure why that was, because they normally spawn in the spring, so I would have thought that they wouldn't have been as flow limited as the habitat would have suggested. But another sucker species had a different relationship. They're also in the river. They're a very similar species. They're called long-nosed suckers. So we used that species for the sucker spawning bioperiod. We did not use long-nosed dace adults, long-nosed dace spawning, we could not fit long-nosed day spawning within a specific bioperiod. It kind of spanned multiple bioperiods, and we felt that we had sucker spawning covered, we had anadromous fish and resident minnows covered by 2 bioperiods. Therefore, we did not need a species that was kind of midway in between them, and that also would have sort of messed up the time series and U-cut analysis. It would have been difficult to interpret, as if it's not difficult enough to interpret. Let's see, what else? Common shiner was one, for spawning, was one that we also dropped out because it was similarly, it was high flow limited, but we had other species in that bioperiod that covered it. Pretty much everything else we did that we thought we were going to do. As you can see, for rearing and growth, there was a lot of species, and also adults and juveniles of each species. We did not, we did start developing curves for young of the year and fry, which are early life stages of these fish. However, all of those curves were high flow limited. Those life stages really like slow water areas. So trying to, if you were to define a minimum flow, it would be very, very low and wouldn't really be protective of the needs of the other species as well. Now we boiled that all down to this table here. So based on all of those different species we evaluated in every bioperiod, we chose our thresholds in those U-cut curves. If they were determined to be protective of the rest of the species or metrics based on having higher flows or lower durations. So species that needed higher flows than other species in the same bioperiod to maintain their habitat were considered protective of the species that didn't need as much flow, essentially. So this was a conservative analysis, finding the one species or maybe 2 species or suite of species that protects the rest. And again, I don't expect you to read this whole table right now. I have a slightly blown up version at the end of this presentation. But these were the results of our fish habitat analysis with the U-cut curves. It defines the common flows, durations, critical flows and durations, and rare flows and durations in a way that DES can take it and then manage the flows in the river. These selected values would be protective of habitat for most or all of the species and life stages assigned to a given bioperiod. And as I stated before, most protective habitat thresholds were represented by higher flows and or lower durations of the habitat limitation events when compared to the other species in the river. Before I go on to riparian habitat, does anybody have any questions about fish and aquatic? Yes.
I'm just curious, like what kind of feedback you would expect from, say, the common individual. It seems to me people who comment on this are going to be people with science backgrounds who are going to really, truly be able to evaluate this. I mean, someone who's an angler, are they going to make any sense out of this? Are they going to be able to comment? I mean,
that's a good question and something I think we grappled with and New Hampshire DES has grappled with, with this type of methodology. And I don't know what experience you guys had on the lamprey and Salhegan.
Maybe just comment on that really quick. Is that so? I'm Ted Deers. Nice to see you all. When the slide that he just showed, which shows the actual values, that's what I think we want people to sort of think about. Because when we did this on the lamprey and the Salhegan, when you get to the end of the presentation and you have, okay, these are the values that we think below this point for this many days is really potentially dangerous for the biota within the stream. That's what we're saying at that point. And I think it's what we're looking for people to think, yeah, you know, I know what that looks like. I know what those flows kind of look like. I've seen them on the river. I've been out there. I fished for in these streams. I know what the flows are because I looked at the USGS gauge. It's right here. So does it seem, yeah, like this is getting bad when we get to those levels? That's what we're looking for, because it's really that on the ground look at how did you actually get to the end has been well researched and has been really vetted through lots of science. This is sort of the cutting edge of how you do in-stream flow around the country. But what really matters is, what does it really look like at the end? Does it really make sense to you? Does it pass the smell test at the end of this? And that's what we're looking for comments. And so, yes.
So you're saying that previous chart, or the one that you're going to show at the end, is basically what the angler should look at and say, yeah, this makes sense to me based on what I normally experience on this river.
Exactly. Right? That's exactly what we're looking for. And that's because that's the proof is in the pudding, really, is did you go through all of these crazy machinations with lots and lots of data from the field and lots of electrons being pounded against each other in the computer, and did we actually get to something that seems like for real? And that's what we're looking for. Absolutely.
That was a good description, Ted. Thank you.
I handle the easy questions. He gets the hard.
Okay, anything more on fish and aquatic? All right. So moving on to the floodplain transect method for riparian habitat. This one's a little simpler, I promise. So to give a general overview of riparian ecosystems and wetlands, so there are plant communities and wetlands within the river channel and floodplain that rely on flows in the river to maintain their community structure. And this is typically driven by moderate and higher flows than we would see driving the aquatic habitat. We can see here a diagram that shows where some different types of habitats exist kind of up the river bank from left to right. Down low we have the riverine areas. On the bank we have palustrine emergent wetlands, which are wetlands that have plants that kind of come up out of maybe some water or wet soil. We end up getting into scrub wetlands, which are basically what it sounds like. They're kind of shrubby compared to the smaller emergent vegetation. And eventually we get to these PFO or palustrine forested wetlands that are in kind of the higher areas that the river might relatively rarely reach when it floods. So the floodplain transect method, we selected transects in locations with exemplary natural communities and riparian wetlands. We performed topographic surveys at each transect from one bank to the other. We performed riparian ecosystem and vegetation surveys along each transect, so going along, identifying the species that are there, classifying it into different community types, wetland types. We installed water level gauges at each location, and we documented water level at a range of flows to determine, okay, at what level does this type of community along the bank get inundated? And based on the level at that time, what was the flow at the gauge? So we can correlate it back to the USGS gauge. We evaluated what ecosystems and vegetation were inundated at the various flow events based on all of this data. So this is just a slide of us collecting a bunch of data at these transects using a total station, documenting the river channel and its floodplain elevations, performing the detailed vegetation surveys consistent with DES protocols, delineating the habitats across the river, and then installing these loggers from July 2020 through April 2021, capturing a maximum flow that year of about 3,730 CFS, which wasn't as high as some of the major floods, but we were pretty happy to get that flow, especially last year on our data set, given that it was such a low flow year in 2020. I don't expect you to read all of this. The information kind of shown on the plot, all those little lists, those are all species. Those are species in a specific type of community. And these are all in a report, in an appendix of the report that can be, probably viewed easier and interpreted, as you see fit. We use that topographic survey. You can see the kind of the yellow line in the middle where it starts out on the left up high, and it kind of dips down and levels out and then dips down into the bottom of the river channel and comes back up. That's a topographic survey across the stream channel. And those different colors and different lists, those are the communities along that channel. The lines that are straight, so the black line, the solid black line toward the bottom of the plot that's across the bottom part of the river channel, that was where there was riverine wetland habitats, and that was inundated at about 45 CFS at the USGS gauge. Moving further up to inundate most or all of some of the next habitats, it bumped up, you needed a lot of flow to get up there. So up at that next kind of bench along the cross section, that was at about 1,860 CFS. And then the highest flow pretty much wetted the entire channel out pretty far, even up into some of the forested wetland areas at about 3,700. So that was what we typically call a kind of a bank full event, where it was right up into the whole channel, maybe even slightly higher than bank full. So again, I don't expect you to read every single number on this table. It's in the report if you want to go through the details. This just demonstrates at each transect where we saw the flow coming up to inundate different communities at each location. So there was a couple of different patterns that we did notice across the river, across all 6 transect locations. That was most of the forested wetlands weren't inundated during the study period. The riverine habitats were inundated approximately. I don't think that's necessarily right. I think this slide might be a little bit wrong. I think it was the PFO wetlands were inundated on approximately like 10-year flooding event. The slightly lower emergent wetlands and scrub were inundated at approximately every 2 years. And then the side channels and mid-channel bars, like down in the river, were inundated multiple times per year. To summarize and wrap things up, the protected in-stream flows were driven primarily by aquatic habitat. We did all this analysis on aquatic habitat. We got a lot of information, a lot of data crunching done, a lot of modeling. And in the end, those seem to be the major driver of these protected in-stream flows. Riparian habitat recommendations were really related to flood frequency. So how often do you need to get a certain size flood to affect the shoreline areas? Boating doesn't appear to be a commonly used resource on the river. None were documented during recreation, and when we were in the field many times, we never saw anybody boating. Evidence that we found online was relatively old, sporadic, and anecdotal. But recreational flow needs, such as swimming and angling, and even any boating that might occur, would be protected by the recommendations for aquatic and riparian habitat that follow this natural flow paradigm. So you can see here, this is our final result. We can see that in each of these bioperiods, they have a date range associated with them. The highest flow thresholds for aquatic habitat, which, like I said, are the major driver here, tend to be in the freshet and in the springtime. The lowest recommended protected in-stream flows are in the summertime, and then there's some kind of mid-range ones in the fall and overwintering, which also made sense from a hydrology perspective, not just a habitat perspective. And at the bottom below the table, we have the recommended flood frequencies, which were based on the riparian analysis. That's really the end of the presentation. I'd be happy to go into more detail on anything anybody wants me to go into, or if you have any questions. So this is all in the report, which Wayne posted online. It should be readily available for people. Any further questions, comments, good jokes? Yes.
So I'm trying to understand, how did you use the information about riparian habitat?
Riparian, yeah, the riparian habitat. We had those stream cross sections at 6 locations. We knew, for example, the elevation of certain wetland types or certain, communities, I should say. And then we gathered the water level information, which told us how far up the water had to come to inundate it. And also, when the water level was up to a certain point, we knew what the flow in the river was as well. So we could tie that back and say, okay, at this flow, it's going to inundate these wetlands.
But could you tie, like, the frequency of the inundated wetlands to the actual fisheries in terms of whether there was any interdependence on those particular wetlands in order for the fish, or can you make any connection there?
We did not tie the two together. They were separate assessments. We didn't really have species here. I mean, we had species where the sides of the river can be important for cover, but we didn't have a lot of species. Say, for example, some species like to spawn in a floodplain when the river comes up. We didn't really have any of those here that were in the target fish community for this river. But in general, for this study, and I think previous studies, they're generally two very separate methods that are evaluated independently for the different communities. But I probably didn't see a need to combine them in this case.
So you're saying that the target fish communities did not warrant or seem to indicate a need for specific riparian habitat, or we're not dependent on a specific habitat?
Yeah, our habitat model also only went up to 255 CFS. At that point, though, most of the curves were starting to level out or even go down. So at the higher flows, they were actually losing habitat, which is important for an analysis like this, that you don't go too far beyond that when evaluating a minimum flow. When the river flows come up that high too, fish tend to move to areas where they can get behind rocks, get up close to shore, kind of hunker down. They're not necessarily performing day-to-day activities like they would when the flow is lower, at least these species that we have in this river.
So things like wetlands used for just like nurseries or, smaller fish, I mean, there was none of that kind of correlation.
We didn't, like I said, we didn't evaluate fry, which might use some peripheral areas, but the fry, when we started trying to evaluate fry, they really only liked low flow. So we couldn't really incorporate that necessarily into this because they wouldn't have been protected, or a lot of the other species would have had very, very limited habitat if you tried to protect fry only.
But I think one of the answers to your questions is that indeed, the biota of the river, both flora and fauna, evolved together, right? So they're both very necessary to each other. But when we looked at it from a flow perspective, they're not necessarily influenced by the same flows. And that's the purpose of this particular exercise, is to do that. Riparian zones form all kinds of important relationships back with fish. from temperature moderation to water quality amelioration, from provision of nutrients. All of those are so critically important of riparian wetlands. Those are all really good reasons to protect your riparian wetlands. But this study doesn't necessarily reflect those two because it's mostly focused on flow.
So I'm kind of wondering why you bothered to do the riparian systems, ecosystems.
The idea here is that the natural flow paradigm, you expect certain high flows to happen in the springtime, and you expect low flows to happen in the summertime. Within that summertime period, you expect variability of highs and low flows when you have storm events, and you expect to see those things happening on a certain duration and frequency. Well, you need that information to support fish, because the problem is that fish generally are stressed the most, at least the flow-loving fish are stressed the most during the times when the flows are very low. The riparian vegetation, that natural flow paradigm idea is that there's supposed to be high flows too. But if we're only looking at low flows for fish, we're not understanding what the flows are for the high flows that are needed. So what we want to do is see that range of flows that are supported by the fish, and we need to measure those protections, that the low flow protections that are supporting the fish. But then we also need to know, to support those fish, you need to have these things that go out into the wetlands, that go up onto the banks and change the riparian vegetation, because the riparian vegetation affects the stream. When trees fall in, when leaves fall in, all those things are supporting the stream on the riparian banks, plus the wildlife that's on those banks need to be supported by the higher flows. So we're looking at trying to identify what do we use to determine the low flows, and that tends to be the fish. What do we use to identify the moderate and the higher flows? That tends to be recreational uses and the riparian vegetation. If we track those things, we may not be able to manage to create a high flow that would flood out onto the riverbanks. There's nothing I can do. I can't release enough water to make that happen. But we can track that information if we know where the important points are. So what they did with the floodplain transect, they identified those points, those special extents of the vegetation on the banks, went up to a certain height. That certain height has a certain flow associated with it. Well, now I know that I need to be careful of what happens to those particular levels of flow, or that height of water, that amount of flow that comes up to that level. I need to track that over the years and identify whether that's continuing to happen. If it's not continuing to happen, there's not a lot I can do about it, but I can identify that as a problem, as a reason why we're not getting riparian vegetation being supported as it should be. And maybe then we look at things on a larger scale than trying to manage water use and with dam releases. We start looking at watershed-wide management of things like impervious surfaces and how much land use gets changed, and things that are going to affect the higher flows more than they are manage the lower flows.
So that kind of information would be reflected in the watershed plan, not on this report.
Not on what? I'm sorry.
Not in this report.
This report defines both the fish flows that are the low flows that generally, and it looks at the recreational flows, and it looks at the higher, so it goes through the spectrum. The natural flow paradigm says you need low flows, but you also need high flows to support the fish. But even though they're not happy, you need to have the high flows to do things like change the channel and make sure that the riparian vegetation is either cleared out or swept and scoured and turned in. So you need to know what those flows are so you can determine whether they're continuing to happen.
So my question is, where does that get reflected? It's not in this report.
Where's
Well, I mean, here, but I mean, more of a narrative that describes that interrelationship. Isn't part of this process also include a watershed plan?
That'll be the next step.
watershed?
And that's what I'm saying, and
You have to be
then,
careful what we call a watershed plan, because there's a watershed plan that the Rivers program does that you guys do for your quarter management.
well, we do quarter in our watershed.
And then we do a watershed management plan, which
Right.
applies to affected dams and affected water users.
Right,
And those things are two different plans. In that plan, we will document what we can do for management, what we should be paying attention to. So the floodplain transect things, we will say, well, we're going to track that over the course of years and determine whether or not we're maintaining those riparian species by making sure those flows happen on that schedule that's on the bottom part of that chart. So we look at that. It just takes a long time for that type of data. I mean, if you're looking at something that's a flood flow that only happens once every 15 years, then it takes 15 years to even see one of them maybe. And to see a trend in whether that's happening or not, it might take decades to determine whether or not that trend is being maintained.
So my question is that kind of information will emerge in the watershed plan, not
In the water management plan.
water management.
Yes, that's the type of thing that we say, we're going to track this and make sure that we see, like for the Lamprey, we look at, I think it was 325, maybe it's 275 cubic feet per second is where you could recreate by channel, taking the hose down the channel without actually having to drag the hose out at any point. So that's something we would say, well, are we seeing that flow happening the same number of times during the year when people want to use the boat for boating or not? If we start seeing all that time is shifting into December, or we're seeing nothing, it never happens again in the months in the middle of the year, where it used to happen twice a month, those types of things are, that's a very complicated process to determine trend on things that are so rare, but it is part of the process that we are doing for the Lamprey and South Eating, we will be developing here and on the shore.
Okay, so in terms of, once this is completed and accepted, what's the time frame for that water management plan to follow for the Cold River?
It's largely based on how much time do I put into it and how complicated are the processes. Here we have only one water user, we have 2 dams. It's going to be fairly straightforward, although there's a lot of details that the one water user will need to figure out what it is they want to do. And then there's a 5-year implementation period of the water management plan. So we say, here's what we want you to do, and they agree this is what they were willing to do. And then they do it over the course of the next 5 years. They actually have an extension period of another 5 years if they can't get it done in that time period. But it's all moving them towards developing their conservation plan and developing these management plans that say, here's what we're going to do when stream flows get low. Here's what we're going to do, day to day with water conservation. So it takes several months for the water management plan, and on the Australia, there's a lot of people. There's a lot of planning that's going to have to be done. It's going to take a while. So for that particular river, it's not going to be quick and easy. There's going to be a lot of dams involved for management. The 2 separate processes, really. The water users, they either have a direct and immediate impact on the stream flow because they take water out of the river, or they have a delayed impact, and that determines whether they get, if they're directly out of the river, they get more immediate management plans. If they're far away from the river, they may have no management plan at all, because by the time you tell them to do something, the flows are generally back to what they should be. So whatever they do doesn't change anything. So those are the kind of things that have to be sifted through, and you determine what you're going to have each water user do, and then you get them to buy into that process, and they get a conservation plan regardless one way or the other. And then we also say, all right, at this stage, we've done the best we can with managing water use. Now we're also going to do, if it gets to the point where water use and natural changes in stream flow from rain and precipitation aren't meeting the protected flow criteria, well, then what do we do with dam management? Can we release water from certain places in enough quantity without damaging the ecosystem in the lake to support the stream flow, so that there's a little bit of balance between holding back all that summertime water in the lakes so that people can recreate versus having a little bit of that water downstream. Usually in a larger lake, it's a very small amount of water that is needed to change the stream dramatically, and very little effect on the lake at all. So these are the kind of things that we look at and we calculate and we balance, and we kind of go back and forth with people and try to find out what's the best balance of supporting the protected flow criteria and managing the other things. We don't want to create problems with water quality on lakes by protecting the streams and vice versa. So this is where we try to look at all the different avenues of what changing conservation, changing water use, and changing dam operations to make it work so that these protected flows can be maintained.
So like I said, one of the things important on this river, or cold, to remember is that one of the benefits of going through the process that Ian has spent lots and lots and lots of hours doing, especially for a place that's relatively undeveloped like here, is that we're helping to establish a baseline. So what would be interesting is that over time, this beautiful hamlet is going to become more and more attractive to people because it's a very gorgeous place. And as that happens, people are going to want to use more water. And as that happens, those people need to understand that when they come in and want to use water, that there's a baseline here. That their management plan is going to reflect the needs of this river. So when people come in and want to use water, it's reflective of the needs of this river at this time and moving forward. And so it seems a little silly because there's not very many water users or dam owners, but it's such an important river and such a beautiful resource that understanding and protecting the baseline is really super important. And so that's why this is going on here. Even though there may not reflect a lot of management actions in the near term.
There may not be a lot of stressors on this particular river at this stage, but by developing the criteria which should be protected, we know where the thresholds are for saying, if someone wants to take a certain amount of water out, usually there's plenty of water available, but there's going to be times when we know the record shows that the stream flow is much lower than that, and there's times when they're just going to have to say, what am I going to do during that time to get the water that I need? And this is where the management plans come in. Maybe they find their water from a different source, maybe they go through a well that's further away from the river so that they're not affecting the stream flow. So these are the types of things that just the program being in existence at all will direct people towards making decisions that aren't just, there's water in the river, I can take it. So.
Other questions? Anyone online have questions before we adjourn?
Yeah,
Go ahead.
I put a question in the chat.
Oh, okay. For some reason, I'm not seeing chat.
Yeah, me either.
Okay, I'll just tell you. I was curious if there's any endangered or threatened freshwater mussels in the Cold River, and if so, were their habitat locations taken into consideration specifically as you were looking at flows or, inundation levels?
Yeah, we did not encounter any endangered mussels, and I don't believe we documented any in the literature either. Based on what was observed in some of the other river systems they've evaluated, mussels weren't really as sensitive to the flow regime, or these minimum flows, at least, as a lot of the fish species. So because we didn't really find much in the way of mussels, and there were no RTE species documented, we did not evaluate them as part of this assessment.
But I'm assuming as you move on to potentially other rivers where there are endangered mussel species, that'll be a consideration as you're thinking about transect choices.
It would be, I would think. I haven't encountered any on any other systems at this point.
I'll kind of jump into here because we know we have endangered mussel species on the Ashuela. And one of the things that's going to be...
Can you hear? Can you hear that okay, Kathy?
Yep.
Okay.
One of the things that we encounter in the natural flow paradigm, besides the time of the year and those bioperiods, the durations and the frequencies of magnitudes, the other part of that is also the rate of change. And what we're going to likely only incorporate, not during the protected flow criteria, but during the water management plan, is the rate of change that we allow people to fluctuate the river, so that if you have a population of endangered mussels, you don't want to see that the riverbanks, the shallow margins, those changes can happen as a result of water withdrawals, at least, because of large water withdrawals. We will manage the rate of change that will not allow that type of dewatering that would strand these mussels on the riverbank. So those are the types of things that, once we've identified the location of those mussels and how stream flow would affect their beds, then we would identify in the water management plan part of this, as part of the water use plan, the changes that water users could have that would affect dewatering the beds. So that's where we are planning to address things like endangered mussels.
Cool. Any other questions? All right, Wayne, you gonna bring us home here?
I think we're pretty well done here, so the next step is in more than 15 days, we have the opportunity to have a public hearing. And that public hearing again is on November 17th, no, October 18th. So on October 18th, we'll be back here to, I can't talk about this. We'll be back here to hold the public hearing, which is when the formal comments can be heard in public, and but largely I'm looking for written comments to be emailed to me or to be mailed to me on any kind of topics that are pertinent to the protected flow criteria that have been developed. And again, we will use the criteria that are written in the in-stream flow rules to determine what that means as far as making any revisions to the protected flow criteria for the Cold River. And that will end after 30 more days, so that would be the November 17th. At the end of the day, we would take all the comments that we've received, review them in light of the protected flow criteria, and make any revisions that are supported by that review, and come out with a final protected in-stream flow report that would then be covered over. They'd be led with a establishment declaration document that's basically a summary of the protected flow criteria, describes what the science was that supported that, describes how this would affect the affected water users. There's several criteria, all of them very carefully described in the rules. So that establishment declaration and the report will go to the commissioner, and the commissioner will make a determination on whether or not to use those as the going forward as the flow, water quality standards for flow for the Cold River. So that's pretty much it in a nutshell. From there, I take that final determination and develop that water management plan to apply to the affected water users and to the affected dam owners to see what I can do with those tools, because there's only limited effects on stream flow, but we have to work with to manage the stream flows. And we will take that and generate a water management plan, which will go through a similar process of information meeting and public hearing and then final approval, adoption by the commission. So that's the process that will be going on for the next probably many months, upwards of a year, I would expect. So, with that, it's pretty close to 8:30. We can sit for another 4 minutes. If everybody's ready, you can all head home. And I don't think there's any more comments online, but no questions online. You sure you guys don't want to talk about U-cut curves?
I know I don't.
I love it.
All right, well, thank you all so much for being here. Appreciate you coming out. All right, so we're gonna leave the call. Thank you online as well.